All right, so let's just quick. I'm going to pull in an equation that we've already solved a couple of times. So we've already solved y double prime plus 5y prime minus 6y equals 0 a couple different times. What did we get for this? Or our y1 and y2 earlier?
1 and minus 6.
Yep. So I had e to the minus 6x and e to the x, right? And then a minute ago we had this this problem where we had, so if we had y double prime plus 5y prime minus 6y equals, and earlier we had 6e to the 3x, right? And then our y particular had a form, right? So we guessed y particular was a e to the 3x, right? Now, I'm going to throw a sort of wrench in that works, and I'm going to purposefully make a right-hand side that sucks, and then we'll fiddle with it a little bit. So I'm going to look at this other equation where we have y double prime plus 5y prime minus 6y equals 4e to the x. Now, your natural inclination for solving these things should be to look at this right-hand side and say what? What's your kind of good idea for a guess over there?
Y equals a times e to the x.
Yeah, perfect. You're going to look at that right-hand side. You're going to say, hey, there's a e to the x over there, so I'm going to guess a e to the x, duh, right? And then we're going to calculate yp prime. So we're going to get a e to the x again. Calculate yp double prime. We're going to get a e to the x again. These are a little boring. We're going to take these. We're going to plug them in, right? So we're going to get a e to the x plus 5a e to the x minus 6a e to the x. And this is supposed to equal 4 e to the x, right?
Equals 0.
I mean, this is how we've been doing it.
Mm-hmm.
You just cram it in, and then it works, right? What's the problem?
It's 0.
Oh, shit. So now I'm supposed to set 0 equal to 4 e to the x? Where the heck did my constant go? So let's backtrack through what just happened here. Where the hell did my constant go? What did I guess?
It's gone, reduced to ashes.
Exactly. I reduced it to ashes. I did that on purpose. I mean, I didn't do it on purpose, but I kind of did it on purpose. I should have known that that was going to happen. Right? This is like, okay, so I'm trying to think of something really dumb that I've done on purpose before. Well, yeah, I mean it's a little bit analogous to being like, oh, I'm going to use lava for lights in my Minecraft house. Oh wait, my Minecraft house is built out of wood. Right? Like, this is, you did this. You were the person who introduced this fire into your mess. So why should I have known better? Where was the obvious, like, your house was built out of wood, dummy?
The constants at the 0? I'm not sure. Okay.
I know that's a homogeneous solution, right? I know that e to the x solves this thing. And so, big surprise, when I plug a constant times e to the x, I know this thing solves the homogeneous version. So I know that's going to go away. It has to go away. It can't do anything else. So in order for me to get this particular solution, I need it to not go away. So what happens here is you say, okay, look, So I want this thing to persist through one more derivative. How am I going to get it to persist through one more derivative?
Add an extra x.
Okay. So
Or, no, I don't know. Add a constant in front of the x or something.
So you want to guess a times x plus e to the x?
No, I was thinking like e to the x squared or something.
Oh,
I don't
that's
know. I'm just throwing out ideas.
Yeah, no, that's a good idea. That's exactly what we're doing. So let's try a e to the x squared. Okay, so then what's yp prime?
2ax e to the x squared.
Perfect. And yp double prime
4x
is
squared a.
4a
Oh wait, no, you
x
have to
squared e to
product
the
rule.
x squared plus
2x, or no, sorry, 2a e to the x squared.
Okay. So now I'm going to plug all this in, right? So I'm going to get yp double prime. So I got 4ax squared e to the x squared plus 2a e to the x squared. Let's see, where did the rest of my equation go? Plus 5 times yp prime. So that's going to be times 2x. Oops, 2x a e to the x squared minus 6. Oh, geez, I'm going to need more space. Uh-oh. Where did all that come from? Crap.
I realize now what you meant before, because in our last problem we did use e to the 2x, despite that being a homogeneous solution.
Mm-hmm. Yeah, and it should have occurred to me that you guys didn't yet know that that was going to be a problem. So, all right. So then I need a e to the x squared here, and this is all supposed to equal 4 e to the x over here, right? Okay, so now what do you guys see in here? Anybody see an obvious problem? I see like a whole bunch of constants to sort out, right? What else?
I don't see it going away.
Yeah, I don't. I got e to the x squareds on the left hand side. I got e to the x's on the right. Shit. This is a really solid try. I don't see a way to make it work. So let me give away a little bit of punchline in the interest of not spending tons of time guessing. Let's guess yp is ax e to the x. I think throwing another x in there is a good idea. I'm going to throw it in this way because I think that the product rule is going to keep them kicking around. So we're going to look at yp prime. What am I going to get out of yp prime?
Ax e to the x plus a e to the x.
Perfect. And then yp double prime. And this is where these seem like they get really annoying, but they're not so bad because you just differentiated a constant multiple of whatever is here. In this case, we just differentiated the exact same thing. So I get the derivative of that first thing. And all this stuff came from that guy. Oops, I guess that arrow was pointing the wrong direction. Came from that guy. And then I also get an a e to the x, which came from this guy. You guys with me on that? Okay, now I'm going to go ahead and plug all this stuff in, and something really rad happens here. So I'm going to take this whole thing, and then I need a plus 5 times, and then I need this whole thing. I might this is the only thing about teaching online that I might actually want to keep. I may actually want whiteboards that I can copy and paste on for teaching this one particular class. Because otherwise I end up writing down all these letters over and over again. What's this supposed to equal?
And 4e to the x.
Perfect. All right, now here's the frickin' miracle here. You go ahead and FOIL this stuff out just a little bit, right? Notice this guy here, and this guy here. What's special about those?
They will cancel.
Why do they cancel? How did I know that was going to happen before I did this? What was a homogeneous solution earlier?
0.
Remember, e to the x was a homogeneous solution before, right? So because e to the x was a homogeneous solution, and the way the product rule works, I'm always going to see these guys left out in the cold. They'll always cancel. So if it's a homogeneous solution and you guess x times that thing, all the ones with an x on them are going to cancel. And all the regular ones are going to be left over. So if I collect all my terms here, I've got a 2a e to the x out front. That's this guy and this guy. I've got a 5a e to the x here. That's this guy. And then this is all equal to 4e to the x. So see how this is actually a pretty different equation than what I started with? But it's still doable, right? I can look at this and I can say, okay, so there's e to the x's. We'll just drop all of them. And then we'll get an equation with one equation, one unknown. We can solve this. We get 7a equals 4. And so a is 4 over 7. And then if I go back up, I know now that my particular solution for this thing looks like y is, well, it's the two homogeneous pieces added together. So it's c1 e to the minus 6x plus c2 e to the x plus, and then that particular piece that I got out of method of undetermined coefficients should have been a 4 over 7 x e to the x. That makes sense? So the trick here, what does method of undetermined coefficients mean? In the very simplest case, it amounts to, if you have an e to the x on the right-hand side, you guess that same you guess a constant times that same e to the x. If you have an e to the whatever that matches one of your homogeneous solutions, you need to slap an x on it to get it to persist. Guess what you're going to do if it's a double solution? So in the case that you have like, let's see, I need to construct something where y1 is, you guys help me do this quick. So here's what I want. I want a solution, or I want a differential equation with r is, say, 1 and 1. Can we back that out? What does that mean the two factors are? It's a weird question. I don't often ask these in class, but you guys are pretty slick, so I think we can sort this out. So if I've got two roots that I want to hit, what did those two roots come out of?
It's gonna be a pair of factors.
Good, I need
And
factors.
the solution to each of those factors is the factor equals 0. So it's gonna have to be r minus 1, r minus 1. Yeah.
Perfect. Okay, so now if I think about foiling this out, right? This came out of r squared minus 2r plus 1 equals 0, right? And what's my differential equation that goes with that look like?
Y double prime minus 2y prime plus y equals 0.
Perfect. Okay. So what are the two solutions for that? Got r is 1 and 1. So what does that mean our y1 and y2 are? So y1 should just be e to the x, right?
And y2 also be e to the x, right?
Y2 should also be e to the x, except that doesn't work because then it's the same as y1, and then I really only have one constant, right? So does anybody remember from the section about homogeneous constant coefficient equations?
Isn't it
What-
x e to the x?
Perfect. So this is already kind of a known thing, right? If I have a repeated root, I slap an x on it to get a second solution. All right, so that would mean that my homogeneous solution here, right, is c1 e to the x plus c2 x e to the x. So then my question is, if I have y double prime minus 2y prime plus y equals, oops, not equals 0, but equals, say, 4 e to the x again, what's my guess look like here? So first pass, right? You look on the right-hand side, you see an e to the x. Your first idea is going to be to guess a e to the x, right? Is that going to work?
No, it's going to cancel the 0.
Yeah, that shit's all going to go to 0 because that's one of the homogeneous solutions, right? So this ain't going to work. Not going to do it for you. So what's your next guess?
X e to the x.
Yeah, you slap an x on it, right?
That's also not going to work.
So we're going to guess a x e to the x. Why isn't that going to work?
Same reason.
Yeah, same deal. That's one of the homogeneous solutions too. That ain't going to work. All right, so what's your next guess? Don't get creative on me here.
X squared e to the x.
Perfect. Slap an x on it. Ax squared e to the x.
It baffles me how this works. Like,
Yeah, it's actually really cool. So if you feed this into the product rule, you will see that all the terms with an x squared in them are going to cancel because this thing solved the homogeneous version. All the ones with an x in it, all of those are going to cancel because x e to the x solved it. All the ones without it either are going to be left over, which is going to leave you with one equation, one unknown. You're going to solve it. It's like, bam, works. Sick.
It's so cool. I hate it so much.
Right? Yeah, I feel exactly the same way. I'm just when I first learned this technique, I was like, no, that's too dumb. Why? No, why would that work? And then you sit down and you really carefully, you can sit down and prove to yourself that this stupid thing works, and it works every time. Like, it's not like an accident. It's not like partial fraction decomposition. It doesn't rest on anything hard. It's just a product rule.
I feel like this is almost dumber than variation of parameters. Like,
Oh yeah, method of undetermined coefficients is way. It's in a lot of ways way dumber.
yeah.
Now I haven't gone into it, but there's some other things you can add to the fronts of these. There's a longer video about method of undetermined coefficients that has more of the like very specific things. But this is the philosophy. You just like make an educated guess. If it overlaps one of the homogeneous solutions, it needs an x on it. If it overlaps two of the homogeneous solutions, it needs two x's on it. Wham bam. There you go. Please note, if the right-hand side consists of a sine or a cosine, you will need the other piece. So you will need the complementary sine or cosine as well. Does that make sense? All right. That's what I've got for method of undetermined coefficients for today. That should be the bare basics.